Hello, in this video, I will find the adjoint of a matrix and then the inverse of the matrix. Okay, so look, here we have two problems. Here we have two problems. One is matrix 2, 4 minus 3, 5, and another is 3, 2, 0 minus 3 minus 3 minus 1, 4, 4, 1. It is 2 into 2 matrix and it is 3 into 3 matrix. Okay, let's begin. What? Look, at first, assume that A is the matrix 2, 4 minus 3 and 5. Okay, the solution starts from here. Now, at first, we have to find out the determinant of the matrix. Okay, so determinant of A is we should put this type of symbol. Okay, straight line determinant. This is also the straight line determinant. So what has happened? The determinant of A is 2 multiplied with 5 minus 4 multiplied with minus 3. Okay, so 5 multiplied with 2 is 10 and 3 minus 3 multiplied with 4 is 12, and there is a minus, so plus, so as a result 22. Determinant of A is 22. It is not equal to 0. So A inverse exists. So A inverse exists. Therefore, and now to find out the adjoint of matrix A, at first we have to find out the cofactor of the matrix. We have to find out the cofactor of 2, we have to find out the cofactor of 4, cofactor of minus 3, and cofactor of 5. So cofactor of 2 is 5. Cofactor of 2 is 5. And cofactor of minus 3 is 4. Okay. And cofactor of 4 is minus 3. And cofactor of 5 is 2. Okay, and cofactor of 2 is found in this way. We cancel out this column and this row. What remains? 5. So 5 is the cofactor of 2. Okay, and the sign will change in this way. It is plus minus plus minus. So 5 is the cofactor. 5 is the cofactor of 2. And cofactor of minus 3 is 4, and there is minus as because plus minus, and cofactor of 5 is 2. Here is 2 and it is plus because plus minus plus, and then cofactor of 4 is minus 3, so minus 3, and it is minus because plus minus. Okay, so now we transpose this matrix. The row will be column and column will be row. So row is 5 minus 4, 5 minus 4 is the column, and 3, 2 is the row, second row, it will be the second column. So 3, 2 is the second column. Okay, so this is the adjoint. This is the adjoint. This is the adjoint. Okay, this is the adjoint. Now A inverse, it is known to us, and I have cleared it in my previous lecture that A inverse is can be found by dividing the adjoint A with the determinant. So adjoint A is this 5 minus 4, 3, 2, and determinant is 22. So this is the A inverse. Now we divide each element by the 22. 5, 22, 3, 22, minus 2, minus 2 because 4 after, after calculation, minus 2, 11, and 1, 11. Okay, clear? It is normal step. So adjoint A is 5 minus 4, 3, 2, and A inverse is is this 5, 22 minus 2, 11, 3, 22, 1, 11. Okay, now I am using all this mark. Now there is another matrix. There is another matrix. It is 3 into 3 matrix, and we have to find out the adjoint A of this matrix and the inverse of this matrix. So before before there is, whether there is a inverse or not, we have to calculate the determinant of A. So if determinant of A is 0, there is A inverse does not exist. If determinant of A is not equal to 0, then A inverse will exist. So we have to check. So at first we have to find out the determinant of A. The determinant of A of this 3 into 3 matrix can be found out in this following way. So 3, 3, and we cancel out this column, this row. What remains? Minus 3, 4, minus 1, 1, minus 3, 4, minus 1, 1, and here is plus, here is minus 2. So 2, 2 is there, minus 2. So what remains? This row is cancelled out, and this column is cancelled out. So what remains? Minus 3, 4, minus 1, 1, minus 3, 4, minus 1, 1. And then there is 0 and 0, so 0 and 0, and this row is cancelled out and this column is cancelled out. What means 3 minus 3, 4, minus 3, 4. Here should be this, but since there is 0, so it has no value. So now the second step is this: minus 3, 1. We find out the determinant of this matrix. So minus 3, 1, minus 4 minus 1. Okay, minus 2, minus 3, 1, minus 3, 1, minus 3 multiplied with 1, minus 4 minus 1 with multiplied with minus 1. So after simple addition, we can find 1. We can find 1. So determinant of A is 1. It is not equal to 0. So A inverse exists. So A inverse exists. Now we find out the adjoint A. So before we go into the next step, so we have to find out the cofactor of this matrix A. And after finding out the cofactor, we transpose all these cofactors and transpose, and we get the adjoint. Adjoint. We transpose the matrix after finding out the cofactor. So cofactor of 3 is nothing but we cancel out this and this column, this row. What remains? This minus 3, 1, minus 1, 4, 1, minus 3, minus 1, 4, 1. Again minus 3. So minus 3, the cofactor of minus 3, the cofactor of minus 3, we cancel out this column, this row, 2, 4, 0, 1, 2, 4, 0, 2, 4, 0, 1. Now there is 4, cofactor of 4, we cancel out this column and this row. What remains? 2, minus 3, 0, minus 1, 2, minus 3, 0, minus 1. And now the cofactor of 2 is to cancel out this row and this column, minus 3, 4, minus 1, 1, minus 3, 4, minus 1, 1. And cofactor of minus 3 is we cancel out this row and this column, 3, 4, 0, 1, 3, 4, 0, 1. Next 4, with the cofactor of 4, we cancel out this column, this row. What remains? 3, minus 3, 0, minus 1. 3 minus 3, 0, minus 1. Now cofactor of 0, we cancel out this column, this row, minus 3, 4, 4, minus 3, minus 3, 4, 4. Now minus 1. The cofactor of minus 1, we cancel out this and this. this column, this row, 3, 2, 4, 4, 3, 2, 4, 4. And now, finally, the cofactor of 1, we cancel out this column and this row. What remains? 3, 2, minus 3, minus 3. 3, 2, minus 3, minus 3. Now, there is, and we have to transpose of this matrix. Now, solving this, after solving this, we get 1 minus 1, 0, because minus 3 multiplied with 1 is minus 3, and 4 multiplied with minus 1 is minus 4, and there is a minus, so plus 4 minus 3 plus 4 is 1 is 1. Similarly, 2 multiplied with 1 minus 0, therefore minus 2, because minus is here. And in this way we can find out all the all the elements, all the 12 elements. Okay, and still there is transpose. We have to transpose it. We have to transpose it to find out the adjoint A. And transpose means we convert the columns into rows. So column 1 minus 1 0 is the first column. It will be the first row. 1 minus 1 6 is the second column. Minus 2 3 minus 4, it will be the second row. Minus 2 minus 3 minus 4, and this is the third column. Minus 2 3 minus 2, it will be the last column. It will be the last row. It will be the last row. Minus 2 3 minus 3. Okay, now A inverse. It is known to us that A inverse is nothing but adjoint A divided by the determinant of A. Determinant of A is 1. It is found. So, and there is adjoint A. So adjoint A is this, and this adjoint A is the A inverse. So this is the A inverse. Okay. So in this way, in this lecture, we try to clear how to find out the determinant, and adjoint of a matrix and inverse of a matrix, and hope you have understood these steps and this the procedure through which the adjoint A and the inverse of A can be found out. Thank you for enjoying this lecture.